that support planning, monitoring, and decision-making. So these are the topics that we're going to cover today. We're going to have the introduction. Then we'll see why mobile coverage analysis matters. Then we'll go to what do we mean by mobile coverage analysis. We'll get to see the typical use cases of mobile coverage analysis. Then we'll see which data sets are required to perform this analysis. Then we'll take you through the demos. And after that, we'll have questions and recommendations. So as we all know, mobile networks are now critical national infrastructure. They support communication, commerce, public services, and digital inclusion. As demand for mobile data continues to grow, operators and regulators alike face similar questions. Where exactly do we have coverage? Where are my customers? Where is my network at risk? Who am I serving and who is underserved? And how exactly can we really expand the network? Mobile coverage analysis provides spatial answers to these questions. It allows us to move from abstract KPIs and reports into maps that clearly show network performance on the ground. This is where GIS is key. GIS allows us to bring together the network data, the terrain, the demographic data, and the administrative boundaries into one analytical environment. So what do we mean by mobile coverage analysis? When we talk about mobile coverage analysis, we are referring to the spatial assessment of signal availability, quality, and service reach across a geographical area. This can be expressed using certain metrics, such as RSRP, which describes the general signal strength of a network. We have the SINR, which is the signal quality that describes the quality of the network that the user is experiencing. Then we have the coverage probability, and we have the technology-specific layers, such as 2G, 3G, 4G, and 5G coverage. It's important to distinguish these two coverage analysis. For starters, we have the predicted coverage. This describes the coverage that comes from the radio propagation models and radio frequency planning tools. The second coverage is the measured coverage. This is derived from drive tests and walk tests, and also crowdsourced measurements. ArcGIS does not necessarily replace RF planning tools. Instead, it acts as a spatial intelligence layer that allows us to analyze, validate, and contextualize these coverage outputs. So in this specific slide, as you can see, this first one, we have an example of a predicted coverage. This is CE Express, which is a prediction tool. Down here, we have a measured coverage, which is an output from a drive test. And on the right, we have a snippet of what the analysis looks like when done on ArcGIS Pro. So what are some of the typical use cases of mobile network coverage analysis? So some of the use cases involve network information management, network planning and design. We have sales and marketing. We have field operations, network operations, customer experience, and lastly, regulatory compliance. We'll dive some deeper into this. So from an operator perspective, coverage analysis is used to, one, identify weak signal areas and coverage gaps. This allows the engineers to be able to monitor which gaps are there in their networks and how they can come and mitigate these gaps as far as planning is concerned. Also, it supports new site planning and network expansion. This is critical when it comes to executives deciding where to channel more funds to. Also, from a design perspective, it allows to differentiate between coverage and capacity challenges. This is where, for example, when in a crowded place, in as much as you may be having good coverage, the capacity would be overutilized. This will lead to poor customer experience, which needs to be mitigated. So coverage analysis is crucial to this point. When it comes to field operations, as you can see, we had two types of coverages. We have the predicted and the measured. So when it comes to the measured coverage, this is where the field operations comes to play. So this is where the managers send out teams on the ground to do drive tests and walk tests to ascertain that the coverage that's being offered by the mobile network operator matches the benchmark that's set by the regulator. So it's crucial that you have visibility of your network using the analysis so that you'll know which routes you're going to use when you're doing the various drive tests. And also the various outputs will require to be analyzed after the drive tests have been done so that you can ascertain that indeed you're meeting the KPIs set by the operators. After all that is done, we come to the network operations. This is where you integrate all the monitoring tools with the data on the ground. So for example, this is where you monitor the alarms and the various actions done by the team on the ground. For example, if we have a field team that's accessing a telecommunication site and they want to turn off a site, so this is crucial, as you can see, how this affects the coverage on certain areas. As you can monitor the alarms, you can see how the subscriber behavior analysis down here and general network performance. Eventually, all this trickles down to the general customer experience. The main goal, especially for the regulators, is to make sure that the customer has optimum quality of experience. When in as much as you have coverage, you have quality coverage. You just don't have coverage. You're enjoying the quality of service provided by your operator. So once the analysis is done, you can create dashboards where you can monitor the customer complaints, how fast the complaints have been closed, the various tickets, and general coverage gaps and covered population that you're serving. It's also applied on the sales and marketing, where the sales teams send out sales executives depending on, say, the market expansion. If, for example, an operator has added new sites on the ground, based on the network coverage analysis, you can see, or rather you can map out the various demographic that's on the ground. And with this, you can send out the executives to do the marketing and customer activation. And also you can analyze the general annual revenue per user that your users are using based on the demographic data that you can get from ArcGIS. And all this is done via the network coverage analysis. So from a regulatory perspective, coverage analysis helps to verify operator submitted coverage claims, to monitor compliance and license obligations from the various licensees that the regulatory authorities manage, and to support universal service and rural connectivity programs. So this is really critical as the regulator serve as the benchmark of coverage, as they've set these KPIs for the various operators and to serve the various jurisdictions that they manage. So coverage analysis is crucial in this sense, in that the regulators will monitor the various licensees, whether they're utilizing their license as the set service level agreement. Additionally, from a policy and planning perspective, the coverage analysis enables broadband gap analysis. This is essential, especially when you're dealing with broadband mapping, where you map out all your telecommunication infrastructure, including the fiber network, the fiber nodes, the different telecommunication masts, the data centers. All this is quite important. It also enables population and settlement coverage statistics. And lastly, evidence-based infrastructure investment planning. So before we move to the demo, so to perform meaningful coverage analysis, several key data sets are required. So first, we have the network coverage rasters. These are the outputs that you get from either the prediction model tools, the RF planning tools, or the measured coverage from the various tests that we had mentioned earlier. We also require the administrative boundaries. We also need the population data sets. We also need the settlement or land use layers. And lastly, terrain data, including elevation and clutter. So I'll take you through the few demos over here. So I do want to start with a demo on ArcGIS Pro, as this is where you start from when you already have the various outputs. So the first step on this, once you create a new workspace, just a second. So for ease of access of your data, I always recommend that you add a folder connection to your folders and connect them to where you've set, or rather where you've stored all your information. I've already done that in my case. So the first step is adding the coverage, the rasters. So for this demo, I've already added my raster over here. So this is how it looks like when it's raw. Then after that, you need to reclassify this data and to make it into binary information, where we want to understand is this area covered or not covered. For this particular raster, I classified it using the threshold. So to do this, you'll need to use the reclassify tool. So depending on the different technologies, the different technologies have different thresholds. So for example, negative 105 for 4G, anything lower than that means the coverage is poor. So this is how the reclassify tool looks like. So you'll come and insert your raw data here. Sorry, it's loading. Then once you reclassify, you'll get two different outputs of covered and not covered. I've already done this step, so I have the two different classes of covered and not covered over here. So just to clarify, this information is modeling. This is modeled information. So we are not using real information from the mobile operators of Kenya. That's just to clarify. So once you've reclassified your data and you have two binary values of covered and not covered, you want to clip the outputs to the extent of your country. For example, as you can see here, this prediction has spilled over outside Kenya. So you would want to clip this to your extent. So to do this, you're gonna use the clip raster tool under the data management tools. And you'll add the reclassified raster. As you can see, it picks the extents out here. And once you do this, you need to turn on the feature for clipping geometry and maintaining the clip extent. So always do this. Sorry for that. So I've already done that. And once you've clipped the raster, this is what it looks like. Looks like that. As you can see, it's clipped to my extent. After that, you want to add your administrative boundaries. So to do this, if you don't have them stored on your machine, this is how you access it on ArcGIS Pro. So you come here and navigate to the portal. And under ArcGIS Online, you want to search for in this case, I'm using the Kenyan counties, but then again, depending on what you want to display or what you want to analyze, you can put the different administrative zone, be it constituencies or wards, whatever you want. So in my case, I want Kenya counties. Yeah, so you'll have them listed here as feature layers. Then you'll want to add them to the current map. So I already have that in place. So for this step, just to clarify, since for demo purposes, I've only used one raster file. So you'd want to ask, what can I do, for example, if I want to combine different coverages from different operators to form one coverage raster. For example, if you're working under a regulator and you want to do the full, or rather the total coverage, for example, if it's you want to see the total 2G coverage of the country or a certain town or county, you'll want to calculate. Yes, you want to add your raster calculator. You'll use your raster calculator under the spatial analyst tools, and you'll add the different rasters. So if you have, for example, just for demo purposes, I have this, and I want to add this, and you'll give it, let's give it an output name of raster combined. Yeah, so this tool will combine the different rasters. As you understand, different operators may be serving different areas under the same jurisdiction. So if you want to get the combined coverage of the two operators, this is how you'll add the different rasters. So there's that. What's next? So, okay, I'm not using the combined one. So let me continue using the clipped one. So you'll come and check your attribute table and see which attributes you have on this feature layer, the county layer. So as you can see, I have the county names, the population. This happens to come with the population data, but assuming it didn't have the population data and you want to calculate it, you will want to come and use the calculator, the raster calculator. So like assuming you have the population data that you have is not necessarily docked on the county feature layer, and you have it as, say, a dot file, a dot density file or a TIFF file, you'll want to use the raster and multiply it against the coverage. I don't have the population raster right now, but luckily our feature layer has the population here. But this is the census population. We'll dive later into the population when you want to calculate the population and when you want to calculate the covered population. We'll see that later. So assuming we didn't have the population here, ArcGIS also provides the demographic data. So you'll just come again under ArcGIS Online here and search for the Kenyan population. And you can see we have a feature layer over here, and also we can look for the sensors information. As you can see, this is the last census that we did, 2019. So from the latest sensor information, you can add this to your current map and you can utilize it for your analysis. So yes, if you open the attribute table, for the population data, you can see you have the male, the female, the population, and this is done for all the 47 counties. So to calculate your geographical coverage based on this reclassified and clipped rasters, you'll want to come to your geoprocessing tools and go to zonal statistics. As a table. The reason we are using it as a table is the output can be joined as a joint table to our existing county feature layer. So you come zonal statistics, and you need to be careful and not choose the image analyst tool. So the zonal statistics as a table and a spatial analyst tool. So for this, for the input raster of feature zone data, you'll input your feature layer here, the zonal data. These are the administrative boundaries. These. Let me close this. So your administrative boundaries will come here. You have the Kenyan counties. For the zonal field, you're gonna pick in this case, I'll use the admin name as my unique identifier. For the input raster, since we are using the coverage output raster, we'll use this, the clipped one. Assuming we had combined it as I had displayed earlier, assuming I had combined the rasters into one raster for example, TechWise, if you want to see total 2G coverage from different operators and I had combined, I would have picked this. But for the demo purposes, I'll pick the clip here. Then your output table, you can name it whatever you want. So you can call it zonal stats or call it coverage zones, something. Let me call it zonal stats. So for the zonal statistics, since we want to find the percentage of the coverage, you'll come and use the mean. The statistic type will be the mean because we want to see the mean percentage of coverage in that specific zone. That's why you're picking the mean. Then you leave all this and then you'll run the tool. I've already done that. And this is what I have as my output table. So as you can see, this is the mean, and this represents the percentage, the geographical percentage coverage. This is not, I'd like to clarify that this is not the covered population. This is the geographical coverage. So for example, if we say Nairobi, you can say Nairobi is, for example, 100% covered based on the analysis. This is the geographical coverage. For the population coverage, you'll still use the zonal statistics as a table tool. For the input raster, you'll input the population. No, sorry. Remember the zone. This is the administrative boundary. So we'll use the counties, whatever your boundary is that you'd like to use. For the identifier, I'll use the name. For this raster, for the population raster, you want to input the population raster that you have. The rasters that I currently have are the coverage rasters, not the population rasters. But the only difference between the population and the geographical coverage will come here, the statistic type. For the statistic type, for the population, you want to put the sum, because you want to see the sum of all the people that fall under the covered population. Okay, so for my attribute table, this is the output that I have, and I want to add this output to my feature layer, the county here. So to get the percentage over here, as you can see, it's in decimal right now. If you want to get the percentage, you come here and you'll calculate the field. And you'll come and confirm which field has this information. It's under the mean field. So I'll pick the mean and I want to multiply the mean by 100 and apply. So once you do that, you'll have your covered population, geographical coverage here as a percentage. So for confusion, if you want to change this and name it something else, you can come here, open the fields view, and you can change the alias here to covered. Under the fields tab here, you'll save the changes. And if you look here, here, it has applied. So if you want to add more fields here, you can add an uncovered field. So to show that, you can come and call this uncovered. The alias can be uncovered too. The data type, want it as a double. Then under the fields tab, you save it. Come here. And you've added another field. So to calculate this field, you'll come and repeat this process here. And we'll use come in and do this. So since the uncovered will be the difference between the covered and what's not covered, it will be like 100% coverage minus the covered, which is the mean. If you apply, yeah, you'll have added a field that has both the covered and uncovered. So since this is only one raster, assume, I know because I had named it for G. So this is for G. You'll repeat the process for all the other technologies. So if it's for 2G, 3G, 4G, 5G coverage, and you will have the different tables over here. So now you want to add whatever you've gotten as from the zonal statistics analysis, you want to add them to your feature layer, which is the county. So to do this, you'll come and under the geoprocessing tools, you'll come and join. So you'll come and join field under the data management tools. So what this does is it uses the data that you've gotten from the zonal statistics and use it as a join table to the feature layer. So to do this, for example, you'll come and put your input table as this, the Kenyan counties, as this is our feature layer. This is where we want to add whatever we've gotten. Then the field will use the name. The join table now will be the standalone table. This will be the output from the zonal statistics analysis that we did. So for in our case, it will be this. Then the join field has to be the same. So it will be the name. For the transfer method, I usually like to use the field mapping, as you don't want to add all these fields. You'll have a very heavy feature layer. So you'll come and remove the fields that you don't require. So here we remove the name, the zonal code, the count, the area, and we'll be left with the mean and the mean. Remember, the mean we had named it to covered, the alias, and then covered. So this is what we require. Then you can validate your join and make sure that you have all the 47 counties here. Then you run the tool. So I'd already done that earlier. So I have my new table that has the percentage over here. So under the field, save the changes. Yeah, so you can repeat the information here. Yeah, so it has the two, covered and uncovered. So you'll repeat this for all the other technologies. So like once you're done, what do you want to do with this information? So this, from the analysis point, this is where the analysts analyze the coverage. And now you would want to create dashboards from this so that they can inform various decisions from the different use cases that we saw. So to do this, you'll want to share the analysis online. So to do this, you'll come under the feature layer here, the county that you added the join table, and under sharing, you'll come and share as a web layer. So these different web layers will eventually be used to create web maps. And from the web maps, you'll create the various dashboards that can be used by executives, the field teams, the customer facing, the public facing dashboards, all this. If you want to use the raster as a base map when representing your dashboards, you'll want to also share the raster. And to do this, you'll repeat the same process, but under sharing over here, the only difference will be for the layer type. When you're sharing the feature layer here, the one that has the added join tables, you'll share it as a feature layer. But for the rasters, you'll share them as tile. This is crucial as the tile isn't really heavy and won't utilize resources, and will be able to be overlaid as a base map for your dashboards. So I've already done this and I've done the dashboards. So I'll just show you a dashboard here that I did. Yeah, so this is an example of a dashboard that I did, and it's configured to filter the analysis based on the zones. In my case, I'm using the counties. So as you can see, the dashboard is interactive, and it changes based on the coverage. And you can add as many elements on a dashboard as you want. So this is up to the design and whatever information you want to relay. It can be a public facing dashboard. It can be an operational dashboard. And the beauty of ArcGIS is you can integrate your existing systems with these dashboards. For example, you can integrate it using the BSS or the OSS information and alarms. And all these can be integrated into one dashboard that displays this information. So let me see if I have another dashboard here. Yeah, as I said, you can add as many elements. For example, I have a serial chart over here that narrows down the information to this is a constituency level dashboard. You can see you have a serial chart here. It's also configured to be interactive. You can see changes. So with this information, you can tweak it as much as you want. Let's see if I have another one. Yeah, it's more or less the same as the other one. So for this example, this has the covered population. So lastly, I think I have a customer dashboard here. You can have a dashboard that has, or rather displays, the customer complaints, the customer connection type, all this. You can see, you can even add photos to your dashboard here. Yeah. Yeah, as it loads, as we've seen, ArcGIS enables transparent, data-driven mobile coverage analysis by integrating network, geospatial, and population data to support informed planning, compliance, and investment decisions. Yeah, I think I can answer any question.